In the group elements are fluorine, chlorine, bromine, iodine, astatine. Let us write the electronic configurations. Before that, we should know the atomic numbers. Last time atomic numbers paina question అడిగారండి, రైట్. మెయిన్స్లో క్వశ్చన్స్ అడిగారు. 17th గ్రూప్ ఎలిమెంట్స్లో మెటల్ అటామిక్ నంబర్ ఏంటి? 17th గ్రూప్ ఎలిమెంట్స్లో yesterday we have seen it, even I will show it to you also now, right? So fluorine is 9, so chlorine is 17, 17 plus 18 is 35, 35 plus 18 is 53, so 53 plus 32 is 85. So these are the atomic numbers. So let us write the electronic configurations. Cheppali 1s2, 2s2, 2p5. So they have 2 electrons in s orbital, p 7 electrons total in valency shell. 2 plus 5 equals to 7. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. So this is the valency electronic configuration. Bromine is going to be the same thing, so we get 3d10, 4s2, 4p5, whereas iodine is going to be, right, like 4d10, 4d10, 5s2, 5p5, and this is going to be 4f14, 5d10, 6s2, 6p2. So these are the 6p5. So these are the electronic configurations. All the elements have got 2 electrons in s orbital and 5 electrons in the p orbital of the valency shell. So that's why all these elements usually called as 7th group, but if you add this 10, it makes it 17. So therefore we call them as 17th group elements. All these elements are very much abundant in sea water, and sea is known as halous. That's why the elements which are most abundant in the sea are known as halogens. This is the name of the halogens is also given to these elements because they are very much abundant in salt water. We know that sea water is like salt water, so salt water contains so much halogens in it. So this is it. So majorly we'll talk about these elements for physical properties. Physical properties low atomic size increases, right? So but here astatine is the only metal, whereas the remaining are all the non-metals. Fluorine, chlorine, bromine, iodine, all of them are the non-metals. Astatine is only the metal which has some radioactive properties. Otherwise all of them are the non-metals. Since they have s2 p6 configuration, p5 configuration, they are short of only one electron to get ns2 np6 configuration. So that's why they are very violently reactive. So they can react with anything. So fluorine is the supremest reactive element of all the elements in the periodic table. So this is the reason behind it is the ns2 np5 configuration. That's why by hook or crook they try to grab this electron to get octet configuration, right? So these are the 17th group elements. Physical properties lo 2 physical properties you should remember. The first one is atomic size paina evaru adagarandi question adugute, the question will be on electron gain enthalpy, इलेक्ट्रॉन गेन एंथैल्पी या इलेक्ट्रॉन एफिनिटी. इसका आर्डर तो आपको याद होना ही होना है, क्योंकि सो क्लोरीन इज द मोस्ट, देन फ्लोरीन, देन कम्स द ब्रोमीन, then comes the iodine. This is the order of electron gain enthalpy. So element with the highest electron gain enthalpy in the periodic table is the chlorine. And the one more thing, electron negativity you should know it. इलेक्ट्रोनेगेटिविटी का ऑर्डर क्या होना चाहिए? फ्लोरीन ग्रेटर देन क्लोरीन ग्रेटर देन bromine greater than iodine. So this is the the electronegativity. So chlorine is the element with the most electron affinity. Electron affinity. Affinity. So this is very reactive. Yeah, we'll see the introduction part of the 17th group elements here. Yeah, these are the 17th group elements. Just we'll take it out. So 17th group elements: fluorine, chlorine, bromine, iodine, astatine are the members of 17th group. These are collectively known as halogens. Greek halo means salt, gens means bone. Yeah, elements. So salt producers, these are nothing but salt producer. The halogens are highly reactive, non-metallic elements. You have to point this point also. They are non-metallic. Like group 1, group 2 elements of group 7 show great similarity amongst themselves. That's why that much similarity is not found in the elements of the group periodic table. Also there is regular gradation in physical and chemical properties. And astatine, you mark this one, astatine is a radioactive metal. Astatine को छोड़ के बाकी सब नॉन मेटल्स है. दिस शुड बी नोटेड. इसका occurrence चेक करेंगे. फ्लोरीन एंड क्लोरीन आर फेयरली abundant while bromine, iodine are less so. Fluorine is present mainly in insoluble fluorides. इसका कुछ minerals are given. First one is the fluorospar, that is calcium fluoride, cryolite, that is Na3Al(F6), fluoropatite, so that is Ca3PO4 taken twice, CaF2, and small quantities are present in soil, river water, plants and bones, teeth of the animals. Also the fluorine is present. Seawater contains chlorides, bromides, iodides, sodium, potassium, magnesium, calcium, but mainly sodium chloride is present about 2.5% by mass. Seawater contains how much percentage? It's 2.5% of chlorine is present in the seawater. The deposits of dried up sea contain these compounds. Example: sodium chloride and carnallite, that is KCl, MgCl2, 6H2O. Certain forms of marine life contains iodine in their systems. Various seaweeds, for example, contain 0.5% iodine, and Chile saltpeter contains 0.2% iodate. Right? So these are the physical properties of these ones. Just we have to go through it. Abnormalities we have to identify करना है, उसको mark भी करना है. Yeah, the very first one is atomic numbers. Normal है, देख लीजिए, 9, 17, 35, 53, 85. Atomic mass is grams per mole, 19, 35.45. So 79 is the bromine, 79.9. That's why in numericals we'll take it as 80. And iodine 126.9, we take it as 127. So it's 127, right? So astatine is 210. Astatine is a radioactive metal है, यहाँ दिया हुआ है, right? Electronic configuration just we have seen: helium 2s2 2p5, neon 3s2 3p5, argon 3d10 4s2 4p5, krypton 4d10 5s2 5p5, xenon 4f14 5d10 6s2 6p5. Yeah, this is the covalent radius, obviously increasing. Regular है तो we don't have to remember. Ionic radius also regularly increasing, you can check it, right? And ionization enthalpy. Ionization enthalpy should be decreasing. It should decrease gradually. So it should decrease gradually. Ionization enthalpy 1680, 1256, 1142 and 1008. Right. Next one, electron gain enthalpy. This important, and electron gain enthalpy. What is the minus sign represents here? The minus sign represents it is an exothermic reaction, not the value. It's an exothermic reaction. So सबसे highest किसका है देख लीजिए. Chlorine 349 and fluorine is how much? 333. Difference ఎంత ఉందండి? 349 333. So this is 6, this is 16 kilojoules ఎక్కువ ఉందండి అంతేనా? Not much. 16 kilojoules energy, electron gain enthalpy of fluorine is less than the chlorine. Chlorine ka highest hai. So 333, so this comes in the first rank, this comes in the second rank, right? So there it goes to bromine. Bromine is going to be, so third place mein hai, and this is in the fourth place, and the radioactive element astatine के लिए कोई validity नहीं है. Electronegativity according to the Pauling scale, they are given, values are given here. So which one is the highest one here? The highest one is again the chlorine. This thing you should remember. Next one, hydration enthalpy. Hydration enthalpy decreases. Yes, obviously it is decreasing. Melting points increase as atomic masses increase. They are also in the regular manner. Boiling points increase, correct? Density also increases. And XX bond, halogen bond increases as size increases, so it is also increasing. The bond dissociation enthalpy should be decreasing, but bond dissociation enthalpy and electron gain enthalpy follow the same order. आपको relate करना पड़ेगा. Electron gain enthalpy and bond dissociation enthalpy are in the same order. So that is ikkada kuda chlorine is the highest, followed by ये order kuda change అయిపోయింది కదా, we can't compare it. The highest one is chlorine, right? So first one, second one is 192. Third one is fluorine, fourth one is the iodine. So ikkada greater than a, ikkada greater than a, so ikkada kuda greater than a. So this has to be remembered. And E naught values are given. E naught value is known as standard electrode potential. Standard electrode potentials. So meaning of standard electrode potential is, it is the combination of 4 items. यहाँ reaction दिया हुआ है next page में. Bond dissociation, hydration enthalpy. So electrode potential is the combination of, where is it? Yeah, here is given. ये in 3 reactions का mixture is the electrode potential. First one is bond dissociation energy. Second one electron gain enthalpy, third one hydration enthalpy. So on adding these 3, which one gets the most one? The most value is attributed to its standard electrode potentials. So the fluorine has got the highest standard electrode potential here, right? So regular and properties are given. The trends of some atomic, physical, chemical properties are discussed. So all these things we have already discussed. Electronegativity आपको याद करना है, right? So physical properties, just will go through it. So halogens display smooth variation in their physical properties. Fluorine, chlorine are the gases. Bromine is the liquid. Iodine is a solid. Their melting boiling point steadily increase. Just we have seen. Halogens are colored. All the halogens are colored due to due to absorption of radiation in visible region results in excitation of outer electron into higher level. So వీటిలో P5 configuration ఉంటుంది కదా. So if you check the P5 configuration has got 5 electrons, 1, 2, 3, here is the 4, here is the 5. This electron is unpaired. So this unpaired electron is responsible when it is exposed to sunlight. This will jump into the d orbital. This unpaired electron can jump and then go back home. So this transition, dp-pd transition, will create the colored compounds for these elements. By absorbing different quanta of radiation, they display different colors. For example, fluorine has yellow in color, chlorine is greenish yellow, bromine is red, and iodine is violet in color. Fluorine and chlorine react with water, whereas bromine and iodine are only sparingly soluble in water but are soluble in various organic solvents. Right? Solvents such as chloroform, carbon tetrachloride, carbon disulfide, hydrocarbons to give carbon colored complexes. One of the curious anomaly we notice from the 7.8 is the smaller the enthalpy of dissociation of F2 compared to chlorine, whereas XX bond dissociation enthalpy from chlorine towards show expected trends. So this is the chlorine followed by bromine followed by iodine is the order of trending. The reasons for the anomaly: relatively large electron repulsions among lone pairs in fluorine, where they are very much closer to each other. Right? Although electron gain enthalpy of fluorine is less electronegative as compared to chlorine, fluorine is the strong oxidizing agent. Why? So దీనికి రెండు reasons ఉన్నాయి. Low enthalpy of dissociation of fluorine, high hydration enthalpy of fluorine. These are the two reasons why it is there. Okay. Next we'll move to oxidation numbers. Oxidation numbers. So in oxidation numbers, what we have to check here, how the electrons get transited. So they have 7 electrons. Initially we said that they need 1 electron to get octet configuration. Therefore, the general oxidation number of this group is -1 to get octet configuration. They get -1 configuration. Easily they get -1 configuration by taking the electron. So for this, their size is also supportive, their electron negativity is also very much supportive. That's why they show -1 oxidation number. Apart from -1 oxidation number, for example, so this is the S2P5 configuration. So d orbital in except fluorine, d orbital is also present. For example, this is for chlorine. Chlorine has 3s2, 3p5, 3d orbital is present but vacant. So this is in the chlorine, we are not talking about fluorine. We got 2 electrons in s orbital, 5 electrons in the p orbitals. So 5 means there are 2 pairs of electrons and this is empty. In this situation, it has only 1 unpaired electron. Therefore, in this situation, it can exhibit the oxidation number equals to +1 or -1 are possible oxidation numbers when chlorine is in the ground state. -1 is exhibited when it gains 1 electron. +1 is possible when it loses 1 electron. So these are the 2 cases. Next chlorine will go to first excited state. Excited state 1. excited state 1, where what happens? So this electron jumps into d orbital. The paired electron from the p orbital jumps into d orbital. So in that case, so the electronic configuration will be s orbital, p orbital, and the d orbital has got one electron here. You can check, this is very important part here. So here you have two electrons, here you have two electrons, here is one. Now this electron is here. How many unpaired electrons can you count here? 3, right? 1, 2, 3. In this situation, this chlorine can exhibit the oxidation number called as +3. +3 is possible in excited state 1, where one of the paired electron from p orbital jumps into d orbital, right? Next one, we go to excited state 2, where this electron also jumps into this position. So if that is the case, what kind of configuration can we see here? Two electrons are here, two electrons are here. So this is the p orbital with 3 boxes, and this is the d orbital with 5 boxes, right? So 1, 2, 3, 4, 5. So these two electrons are as such, these electrons are not changed, right? So what will happen? You got two electrons here. This is going to be unpaired, this is going to be unpaired, this is going to be unpaired. Here you have two electrons. In excited state 2, this is the excited state 2, you have moved to this, both the electrons are in the d orbital. Now how many unpaired electrons can you count here? So 1, 2, 3, 4, 5. So in this situation, the common oxidation state is +5. I hope you are able to understand it, why it is in +5 oxidation state, right? So we can also attribute to excited state 3. Third excited state can also be possible here. So in that situation, this electron also jumps into here. So this electron also jumps to this place. So if that is the case, we have got one box. Here we have 3 boxes. 1, 2. Here we have 5 boxes, which represents d orbitals. 1, 2, 3, 4, 5. Right. So can you tell now how electrons are organized? How can I organize the electrons now? So the s orbital has got 1, all p orbitals are occupied by 1 each, all d orbitals, no, all not, only 3 d orbitals are occupied by 1 each. In this situation, the count of unpaired electrons is 7, that's why they exhibit +7 oxidation state, right? So these are the general oxidation states. Their common oxidation number is +1, -1, and +3, +5, +7 are also common oxidation state. Question ఏమడిగారంటే ఈ ఆక్సిడేషన్ స్టేట్ ఏ ఎక్సైటెడ్ స్టేట్లో పాసిబుల్ అవుద్ది? +5 ఆక్సిడేషన్ స్టేట్ ఈజ్ పాసిబుల్ ఇన్ విచ్ ఎక్సైటెడ్ స్టేట్, right? And +7 oxidation state is possible in which excited state? So these questions are commonly asked. So I'll write it properly so that you will able to copy this also. All of you, you have to copy these things now. So this is excited state 1. So this is excited state 2. So this is excited state 3. So these are the 3 cases. You should screenshot తీసుకుంటారా లేకపోతే will you write it down? It's up to you. I'll give 1 minute time for this. మీరు మండే కనుక ఆఫ్లైన్ స్టార్ట్ అయితే, ఏ రోజైతే ఆఫ్లైన్ స్టార్ట్ అయిందో ఆ రోజు నేను మళ్ళీ నోట్స్ అడుగుతా మిమ్మల్ని. యూ హ్యావ్ టు షో ఇట్. నెట్వర్క్ వీక్ ఉండే సార్ మా ఇంట్లో అంటే కుదరదు అప్పుడు. Okay, so one more point to be discussed here is about fluorine. फ्लोरीन के लिए ये सारे वैलिड नहीं है. फ्लोरीन का ओनली वन ऑक्सीडेशन नंबर इज -1. फ्लोरीन कैनॉट एग्जिबिट एनी पॉजिटिव ऑक्सीडेशन नंबर बाय फ्लोरीन, बिकॉज ये फ्लोरीन एक ऐसा एलिमेंट है उससे ज़्यादा इलेक्ट्रोनेगेटिव कोई भी नहीं है. सो इट्स नॉट पॉसिबल फॉर टू रिमूव इलेक्ट्रॉन फ्रॉम द फ्लोरीन बाय एनी अदर एलिमेंट. दैट्स व्हाई फ्लोरीन is exceptionally different from all the elements. And fluorine exceptionally different के लिए we have four or five reasons. First one is पहले size very small है. Second one is d orbital is absent. This is the second reason. Third reason is it's highly electronegative. Element with the highest electronegativity is the fluorine. These are the three reasons why fluorine is exception to all the halogens. So that's why we should remember. And fluorine is the strongest oxidizing agent of all the elements because of its standard E0 value is highest, that is like plus 2.8 something is there. So this is the reason why. We'll see this the same thing in our NCERT. The oxidation states and trends in chemical reactivity are given here. All halogens exhibit -1 oxidation state. However, chlorine, bromine and iodine exhibit +1, +3, +5, +7. Right? +1 is in the ground state, +3 is in the first excited state, second excited state, third excited state. Right? So you can also check these ones. In ground state, so you have 2 electrons in s orbital, 5 electrons in p orbital. In this situation there is only one unpaired electron, that's why it can exhibit either +1 or -1 oxidation state. d orbital is unoccupied. In first excited state, so this paired electron is jumped into this place. So there are 3 unpaired electrons are available now. That's why 3 unpaired electrons count for +3 oxidation state. In second excited state, this paired electron is also jumped into this place. Therefore, so you have got 5 unpaired electrons. So 5 unpaired electrons account for +5 oxidation state. Right? In third excited state, sorry దీని కొంచెం గలత్ हो गया देख लीजिए. इसमें ఇలాంటి సిచ్యువేషన్ ఉండదండి. ఇక్కడ ఒకటే ఎలక్ట్రాన్ ఉండాలి. ఎన్సీఆర్టీలో తప్పు ఉన్నది ఇక్కడ. యూ షుడ్ హ్యావ్ ఓన్లీ 1 ఎలక్ట్రాన్ హియర్. షుడ్ ఐ డూ నో, ఐ విల్ చేంజ్ ద కలర్. సో ఇక్కడ ఒకే ఒక ఎలక్ట్రాన్ ఉండాలి. సో ఇన్ ఇట్స్ థర్డ్ ఎగ్జైటెడ్ స్టేట్, సో వి గాట్ all unpaired electrons across s, p, d, f orbitals. So 7 unpaired electrons account for +7 oxidation state. The higher oxidation states of chlorine, bromine, iodine are realized mainly when halogens are combined with small or highly electronegative fluorine and oxygen atoms. Okay, so this point to be noticed here, +7, +5. Higher oxidation states are possible in only fluorides and oxides only. In interhalogens, oxides and oxoacids, the oxidation state +4, +6 occurs in the oxides and oxoacids of chlorine and bromine. Okay, +6, +4 is also possible, but only those are not general oxidation numbers. They are in Oxides and interhalogens oxoacids. The fluorine has no d orbital in its valency shell, therefore cannot expand its octet. So being the most electronegative, it exhibits only -1 oxidation state always. Halogens are highly reactive. They react with metals, non-metals to form halides. The reactivity of halogens decreases down the group, right? So there the reaction is also given, right? So these reactions also we need to check here how these reactions happen. Sir, even sir?
సత్యశ్రీ ఇప్పుడు వచ్చింది సార్, ఆల్రెడీ 1 అవర్ అయిపోయిన తర్వాత.
సత్యశ్రీ
నెట్వర్క్ కనెక్షన్ వల్ల మళ్ళీ జాయిన్ అయినా సార్, ముందే ఉంటే.
ఓకే నెట్వర్క్ ప్రాబ్లమ్ అమ్మా.
Yes sir.
Are you in the Hyderabad or somewhere else?
No, I'm in Hyderabad.
ఓకే అమ్మా, నేను వీడియో రికార్డ్ చేస్తున్నా, యూట్యూబ్లో పెడతా, తర్వాత యూట్యూబ్కి వెళ్ళి చూడు మరి. ద డిక్రీజ్ ఇన్ ఆక్సిడైజింగ్ ఎబిలిటీ ఆఫ్ ద హాలోజన్స్ ఇన్ ఆక్వస్ సొల్యూషన్ డౌన్. ఈ రియాక్షన్స్ ఒకసారి వి విల్ ట్రై టు అండర్స్టాండ్ హౌ దీస్ రియాక్షన్స్ కెన్ హ్యాపెన్, రైట్? సో హియర్ ఫ్లోరిన్, బ్లాక్ కలర్ ఎందుకు సెలెక్ట్ అయ్యి ఉంది ఇక్కడ? ఓకే, సో ఫ్లోరిన్ reacts with Cl minus, Br minus, I minus. దీంట్లో ఏం చేస్తుందంటే ఫ్లోరిన్ రియాక్ట్స్ విత్ Cl minus and releases chlorine gas where fluoride ion is formed. Even fluorine reacts with Br2. Even fluorine reacts with Br minus to give Br2 and F minus is formed. Even the fluorine also reacts with iodine and gives you I2 plus F minus. These reactions are possible. ఒకసారి reactions లో किसका oxidation हो रहा है, किसका reduction हो रहा है चेक करेंगे. Fluorine is in -1 oxidation state, here it is 0. ఫ్లోరిన్ ఆక్సిడేషన్ నంబర్ ఏమైందండి? ఇంక్రీజ్డ్ ఆర్ డిక్రీజ్డ్ చెప్పాలి. ఇంక్రీజ్డ్, రైట్? -1 to 0 it is increased. -1 to 0 the oxidation number has been increased, so this is oxidation. So this oxidation is done by this one, therefore it is an oxidizing agent. Fluorine is an oxidizing agent. What is the meaning of this is, fluorine ka reaction you can do it with NaCl, you can do it with NaBr, you can do it with NaBr, you can also do it with NaI. So when fluorine reacts with these halides, the respective halogen gases are released by the fluorine. So there the fluorine is a strong oxidizing agent. But the reverse is not possible. What I mean to say here, if I give you chlorine and NaF, so ये reaction possible नहीं है. Why? Because fluoride anion, the final destination of fluorine is to get it to -1 oxidation state. To get -1 oxidation state, it is its final one. So therefore already fluorine is in -1 oxidation state. Why it will let chlorine to get oxidized by chlorine? Why? Because so for to oxidize F minus, this must be strong oxidizer than fluorine, but it's a weak oxidizer, therefore this reaction is no reaction. So what is the meaning here? Any halide, for example, you got fluorine, chlorine, bromine, iodine. This fluorine can oxidize all the elements below it. Oxidation is possible, oxidize. Fluorine can oxidize chlorine, can oxidize bromine, can oxidize iodine. Chlorine also able to oxidize bromine as well as iodine. Bromine only oxidizes iodine, right? So oxidation of fluorine by chlorine is not possible. So ऊपर वाले नीचे वाला को ऑक्सीडाइज करेंगे, दिस इज द रूल, एंड रिवर्स इज नॉट पॉसिबल. होप यू अंडरस्टैंड. అర్థమైందండి ఏమైనా? క్వశ్చన్ కెన్ బి ఆస్క్డ్ ఇన్ ఎనీ డైరెక్షన్, రైట్? సో మీకు హాలోజన్ అనేది లెఫ్ట్ సైడ్ హాలోజన్ ఉండాలి, F2. So who is a strong oxidizing agent should be here, and the other one, for example, I take KBr. So what are the products they are expected? Bromine gas is expected and KF is formed. This reaction is feasible because fluorine is strong oxidizing agent. What if I write Br2 plus KCl? Is this reaction feasible? అమ్మా అన్మ్యూట్ చేసి చెప్పాలమ్మా ఆన్సర్. కెన్ బ్రోమిన్ ఆక్సిడైజ్ క్లోరిన్? So this one is not possible. Why it is not possible? Chlorine can oxidize bromine. Chlorine can oxidize bromine. Bromine cannot oxidize chlorine. So this reaction is no reaction. So this thing you should remember here. That's what he mentioned here. The ready acceptance of an electron in is the reason the strong oxidizing nature of halogens. Fluorine is the strongest oxidizing agent of oxidizing halogen. Not only halogen, of periodic table. It oxidizes other halides in solution even in the solid phase. In general, halogen oxidizes halide ions higher atomic number. A halogen oxidizes halide ion with higher oxidizer number. So fluorine can oxidize X minus, chlorine can oxidize X. So fluorine का केस में X could be what? X could be chlorine bromine. Chlorine का केस लो fluorine ఉండదు ఇంకా, bromine or iodine. Bromine has got only one choice to get oxidized, only iodine. It can oxidize only iodine. So these are the few oxidizing properties. The decrease in oxidizing ability of halogens in aqueous solution down the group is evident from their standard electrode potential. इसका रीजन కూడా ఇక్కడ ఇచ్చాడు, ఇక్కడ వాల్యూస్ కూడా ఇచ్చాడు. దీనికి రీజన్ ఇక్కడ ఈ టేబుల్లో ఉందండి. స్టాండర్డ్ ఎలక్ట్రోడ్ పొటెన్షియల్, రైట్? Fluorine standard electrode potential is 2.87 volts, chlorine is 1.36 and 1.09, 0.54. So 2.87 is the highest standard electrode potential for chlorine, right? Yeah, next we'll go for chemical reaction. First one, reaction with water. Halogen when reacts with water, so we will get different types of products here. For example, fluorine reacts with water and chlorine reacts with water in different manner. So here what do we get here? We will get HF and oxygen gas is released here. But whereas here, so we will obtain HCl plus HOCl is obtained, right? So even the Br2 also reacts with water in different manner, which gives us HBr plus HOBr is being formed here. So the first reaction is evident of oxidizing property of fluorine. Fluorine is strong oxidizer than oxygen, so this oxygen minus 2 is been oxidized to 0 by fluorine. Oxygen gas is released when fluorine reacts with oxygen. But chlorine, bromine are not good oxidizers as compared to fluorine. In fact, the oxidizing power of oxygen is greater than chlorine. That's why you won't get oxygen here, but chlorine is being oxidized in this reaction. So that's the point you should remember here, right? So ఇక్కడ చూడండి, chlorine is in zero oxidation state. Chlorine here it is in the zero oxidation state. Here it is in the -1 oxidation state. Here it is in the +1 oxidation state. In fact, it's a disproportionation reaction. It's a zero oxidation state, -1 +1. The bromine has been reduced here. The bromine has been reduced. So here the bromine has been reduced. In the same case, here the bromine has been oxidized. The bromine has been oxidized. So reduction, oxidation, that's why these are the disproportionation reactions, right? So the same thing we'll see in this P block also. Relative oxidizing power of halogen can further be illustrated by their reaction with water. By the reaction with water. Fluorine oxidizes water to oxygen, whereas chlorine, bromine react with water to form corresponding hydroholic and hypohalous acids. This reaction of iodine with water is non-spontaneous. In fact, iodine I- can oxidize it by oxygen in acidic medium. Just reverse of reaction is observed with the fluorine. So here are the reactions here. Fluorine reacting with water to produce oxygen gas. So here this is going to be HF. Whereas X2, where chlorine, bromine reacts with water to form HCl or HBr and HOX. But when iodine reacts with water, so iodine reacts with water, so there is no possibility of the reaction. Reverse reaction rasadu chudandi. The reverse reaction is possible. What is the meaning of this one is, right? So we expect iodine to react with water to produce Hi plus Hi plus HOI per iodate, right? Yeah. या दिस इज द पॉसिबल रिएक्शन. इसको रिवर्स लिखना चाहिए, सीधा क्यों नहीं लिखा है, देख लो इधे. ఇక్కడ ఆక్సిజన్ అండి, సారీ, రైట్. సో రియాక్షన్ చూడండి, ఇక్కడ HI iodine will not react with H2O to produce this one. ఇక్కడ ఏం చేస్తారంటే ఆరో నేను రివర్స్ పెడతా చూడండి, రైట్. సో వాట్స్ హ్యాపెనింగ్, HI is reacting with oxygen, HI is reacting with oxygen and producing I2 and H2O. This reaction is possible, and the forward reaction is not at all possible because of iodine is the least oxidizing, it cannot oxidize, right. And the last point we will see about this anomalous behavior. The anomalous behavior of fluorine is like other p block elements, presence of second periodic table. Fluorine is anomalous in many properties. For example, ionization, enthalpy, electronegativity, electrode potentials are higher for fluorine than the expected from the trends set by other halogens. Also, ionic covalent radii, melting boiling points, enthalpy, bond formation, electron gain enthalpy are quite lower than the expected. The anomalous behavior of fluorine is due to smaller size, highest electron negativity, low FF bond dissociation enthalpy, and non-availability of d valency shell. The most of the reactions of fluorine are exothermic due to small and strong bond formation by with other metals or non-metals. It forms only one oxoacid. Other halogens form number of oxoacids. Oxoacid of fluorine is only one, that is HOF, where this also shows -1 oxidation number. Right? So this is today's class. Right? So are you able to manage this? Okay. Group elements, these form HX type of hydrides. So namely fluorine, chlorine, bromine, iodine. So it's like hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. So this is the structure. As we go down from hydrogen fluoride to hydrogen iodide, the bond length, so this is the bond length, the bond length is increasing. Bond length has elongated or it has been increased. I would say this bond is very longest bond. So bond is very long, this bond is very short. Right? So here three types of questions can be framed on basis of this. If bond is short, the bond is considered as strong bond. If bond is weak, the bond is long, the bond is considered as weak bond. Hydrogen fluorine bond is very strong bond, hydrogen iodine bond is very weak bond. So which bond is easy to break down? So this bond is easy to break it down. This bond is very strong. So two things you can talk about these hydrogen halides. So here the first question can be asked here is, question will be asked here, the strongest acid is, చెప్పాలమ్మా సైలెంట్లో ఉండకూడదు, strongest acid of all. Yeah, the order of acidity, यही क्वेश्चन बार बार पूछा हुआ है, చెప్పొచ్చు అమ్మా మీరు ఇమీడియట్గా చెప్పొచ్చు. సో యాసిడ్ ఈజ్ సమ్వన్ విచ్ డొనేట్స్ హైడ్రోజన్. donor of H plus is known as hydrogen. So here this bond is weaker, so easy to break down, so it behaves like a good donor of acid. So therefore this Hi is a strong acid, it is a strong acid, whereas HF is considered as the weakest acid. So because of this bond, so the strength, acidic strength is Hi greater than HBr greater than HCl greater than HF. This is the order of acidity. Right here order of acidity, HF is weaker than HCl, then comes the strongest one is HBr, then comes the Hi. Strongest acid is the Hi, you have to remember. So this is order of acidity. So acidity का order यही होगा, Ka का order भी same होगा. So Ka of HF is less than HCl, which is less than HBr, which is less than HBr, which is less than Hi. Sometimes it is related to pKa. pKa would be reverse. HF is greater than HCl greater than HBr greater than HI. So this is how the order these three questions. Any question can be asked on basis of this. You have to notice this point. Okay, so can you take it down here? These are the orders, right? So we also see the same thing here. So here is reactivity towards hydrogen, right? They are all react with hydrogen and hydrogen halides, but affinity to hydrogen decreases from fluorine to iodine. Hydrogen halides dissolves in water and form hydrohalic acids. Some of these properties of hydrogen halides are given in the table. Acidic strength varies in this order. This is the acidic strength of hydrogen halides. Strongest acid is Hi, the weakest acid is HF. The stability of these halides, decrease down the group due to decrease in bond dissociation enthalpy. HF bond is the strongest bond, right? So more energy is required to break the bond. Stronger bonds are required more energy, whereas the bond is here is weak, so easy to break down, right? So few values are here. We'll read out these values. So melting points, boiling points are irregular. You can see here. Boiling point check कर लीजिए. HF is abnormally highest. So इसका reason एक ही है, the hydrogen bonding. Due to presence of hydrogen bonding, the HF is liquid at room temperature. Next, bond lengths are mentioned here. The bond length between H and F is 91.7 picometers. The same is 127.4 picometers in HCl. In HBr it is 141.4 picometers, whereas in HI it is 160.9 picometers. So the bond length is gradually increasing. The bond length is gradually increasing. The bond dissociation energies are also mentioned here. The HF bond dissociation enthalpy given in kilojoules per mole is 574 kilojoules per mole, whereas HCl is 432, HBr is 363, whereas HI is 295 kilojoules per mole. So the bond length increasing, so bond energy decreasing. Here the pKa values are given. pKa value and bond dissociation energies are इन्वर्सली रिलेटेड है, वो आपको याद रखना है. पहले एसिडिटी इज डायरेक्टली प्रोपोर्शनल टू Ka and Ka and pKa are inversely proportional. These two are inversely proportional. So the meaning is, so Ka की जगह एसिडिटी बिटोచ్చు. So acidity is not directly, inversely proportional to pKa. Greater the pKa, less is the acidic character. Lesser is the pKa, higher is the acidic character. So therefore, the lowest is found in HF pKa. So this is the weakest, whereas this is the strongest. This is the strongest acid of all, right? So these are about hydrides. దీనిపైన క్వశ్చన్స్ ఆస్క్డ్ ఆర్ ఈ ఆర్డర్ పైన క్వశ్చన్స్ అడిగారు, ఈ ఆర్డర్ పైన క్వశ్చన్స్ అడిగారు, అండ్ pKa values are also regularly asked. So these times you have to remember them. Okay. Next we'll move to oxides. Right. So oxides of halogens are there are many oxides, many types of oxides are known. So which oxides are very common? Just we'll check here. The reactivity towards the oxygen is, halogens form many oxides with oxygen. Most common of them are unstable. Most of them are unstable. The fluorine forms two oxides. One is OF2, another is O2F2. We have already seen them in the oxygen, OF2 and O2F2, where oxygen shows +2 oxidation state here. Here it shows +1 oxidation state. So these things we have already seen it in the 16th group oxygen may we have already seen it. However, only OF2 is thermally stable at 298 K. At room temperature, only OF2 is stable, O2F2 is unstable. These oxides are essentially oxygen fluorides because of the higher electronegativity of fluorine than the oxygen. Both are strong fluorinating agents. O2F2 and OF2 are both strong fluorinating agents. O2F2 oxidizes plutonium hexafluoride, and the reaction is used to removing plutonium as PuFi from spent nuclear fuel. So here is the one usage of it. Plutonium is removed from spent nuclear fuel by the reaction of it. Chlorine, bromine, iodine form oxides in which the oxidation states of these halogens range from 1 to 7. A combination of kinetic and thermodynamic factors led to general decrease in oxidation, general decrease in order of stability of formation of halogens. So this is the order. Higher the oxide of halogen tend to be more stable than the lower ones. Higher oxides are very well known. So chlorine oxides are mentioned here. Chlorine has oxides like Cl2O, chlorine monoxide, chlorine dioxide, chlorine hexaoxide, chlorine heptaoxide. राइट. सो ऑक्सीडेशन नंबर्स आपको कैलकुलेट करना आना चाहिए. यहाँ पर क्या होगा, क्लोरीन का ऑक्सीडेशन नंबर +1, यहाँ +4, यहाँ +6, यहाँ +7 होगा. ऑक्सीडेशन नंबर्स यू कैन कैलकुलेट इट. Are highly reactive oxidizing agent tend to explode. These are explode. ClO2 is used as bleaching agent. It is used as bleaching agent for paper, pulp and textile treatment. Right? And next one, the bromine oxides also the same type of oxides are known. Br2O, bromine monoxide, bromine dioxide. Here bromine trioxide is also known here. Bromine trioxide, chlorine trioxide లో డిఫరెన్స్ ఏంటంటే Cl2O2 దీన్ని డైమరైజ్ చేసేస్తే ఇది వస్తుందండి, Br2O3 వస్తుంది. 2 మాలిక్యూల్స్ కనుక దీన్ని చేస్తే ఇది వస్తుంది. ద మీనింగ్ ఈజ్ Cl2O6 ఈజ్ ఇన్ dimeric state, whereas Br O3 is it in monomeric state. Are the least stable halogen oxides, middle row anomaly, and exist only at low temperatures. They are very powerful oxidizing agents. These are very powerful oxidizing agents. Next, iodine oxides are I2O4, I2O5, I2O7. Right? Iodine tetraoxide, iodine pentaoxide, iodine heptaoxide are insoluble solids and decompose on heating. I2O5 is very good oxidizing agent and is used to estimate the carbon monoxide. కార్బన్ మోనాక్సైడ్ ఎస్టిమేషన్లో కూడా వచ్చిందండి. ఇది ఎక్కడ చూసామంటే మనం where do we studied this one in the GOC में देख लिया है. this part of it is I2 plus CO carbon monoxide estimation lo we will use it. Yeah, next we will move to the next part is the reaction towards the metals. All halogens are very reactive. They react with all the metals available. The reactivity towards the metals are halogens react with metals to form metal halides For example, bromine react with magnesium to give magnesium bromide. These reactions we have already been seeing. The ionic character of halides decrease from metal fluorides in this order. ఇక్కడ మళ్ళీ ఏమొస్తుందంటే we have to think about Fazan rules. Fazan rules ki applications we have to study here. You remember the Fazan rules? What are the Fazan rules? These things we'll discuss here. According to Fazan rules, what it says here, for example, you have anions like fluoride, so you got F minus, O minus 2, N minus 3, C minus 4. So if the negative charge increases, so this compound is like more likely to be covalent. More covalent is more dominating. Here, this compound is ionic in nature. So if you move from here to here, the ionic character decreases, covalent character increases as negative charge increases. Yeah. So from left to right, negative charge is increasing. Negative charge is increasing. The size also increasing. Is the size increasing? Yes. So as negative charge and size increases, covalent character increases. Cation kuda apply cheyochu idi. Na plus anion lo V anion kuda apply cheddam. So we got F minus, right, Cl minus, Br minus, I minus. Ikkada from left to right, the size is increasing. Size increasing. So therefore covalent character increases. So iodides are covalent in nature, fluorides are ionic, even chlorides are also ionic. So this is the order of changing. Okay. The same we will try to read here. So here the ionic character of the metal halides, metal fluorides are more ionic, metal iodides are least ionic. Right, the same order. All fluorides are ionic in nature, all iodides are covalent in nature. So they have got covalent character. Where monovalent metal. A metal exhibits if more than one oxidation state, the halides in higher oxidation state will be more covalent than one in the lower oxidation state. This example, आप देख लीजिए SN4, SnCl4, PbCl4, SbCl5, UF5, where the oxidation numbers of these metals is tin oxidation number is +4, lead oxidation number is also +4, stibbium oxidation number is +5, uranium oxidation number is +6, are more covalent than SnCl2. SN, so దీన్ని కంపేర్ చేస్తున్నామండి ఇక్కడ. SnCl2 SnCl4 ను కంపేర్ చేస్తే, so what will happen? SnCl2 లో +2 oxidation state. I'll write the oxidation states here, +2, this is also +2, this is +3, this is +4. If you compare here, SnCl4 SnCl2 లో హయ్యర్ ఛార్జ్ ఉన్నటువంటిది కోవలెంట్ అయితే లోవర్ ఛార్జ్ ఉన్నది అయానిక్ అవుతుంది. PbCl4 PbCl2 +4 oxidation state +2, +4 is covalent, +2 is more ionic. PbCl5 SbCl3, SbCl5 SbCl3, more oxidation number, covalent character is more, lesser oxidation number, less covalent character. UF6 +6 oxidation state, +4 oxidation state. So this is more ionic, this is less covalent. Right? Questions etla aina aduvachandi deen paina. Which of the following has got more covalent character? Which of the following has got less covalent character? So you have to compare these things with them. How do you compare? SnCl4 is compared with SnCl2, right? So PbCl4 is compared with PbCl2, and SbCl2 is compared with SbCl3, and UF6 is compared with UF4. So the top higher oxidation numbers are highly covalent in covalent character. Again Fazan rules ikkada apply ayyedi chudandi. If you are given Sn plus 2, Sn plus 4, which one forms more covalent? So higher oxidation number, more covalent character, lower oxidation number, more ionic character. That's what he said, right? Na plus less charge, magnesium plus 2 more charge, Al plus 3 further more charge, Si plus 4 further more charge. Irrespective of the metal, if the charge is increasing, what will happen? The formation ability to form covalent character increases. So this is what has been increased here. So UF4 respectively is the order. Yeah, next we will talk about the most important topic is of it is interhalogen compounds. Interhalogens. What is the meaning of interhalogens? Interhalogen means one halogen reacts with another halogen and forms a compound known as interhalogen. So in these interhalogens, halogens react with another halogen to form a compound. So we have three types of interhalogens. One is known as X, 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 and another is X, 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 X. We'll show it with the dashes, right? So here it is 7, here it is 5, here it is 3, this is 1. So these are the interhalogens. These are the interhalogens compounds formed by these compounds. Ikkada ఏంటంటే, so the green one should be higher halogen, and X should be lower halogen. So what is the meaning here? ఎప్పుడైనా మనం కెమికల్ ఫార్ములా రాసేటప్పుడు ఫర్ ఎగ్జాంపుల్ NaCl రాసా, ఇందులో कैटायन साइज बिग होगा, anion size small होगा, right? This is how you write it. Smaller ions are written in the right side and the bigger ones are written at the left side. Why is it? Periodic table lone atlunnai. Left side of the periodic table contains all metals which have the sizes are bigger, and ikkadiki vachesariki sizes small. So the same trend is followed here also. So ikkadiki vachesariki both are halogens, therefore so this must be bigger halogen, this must be smaller halogen. For example, if I write IF7, so this is correct. My bigger halogen is iodine, fluorine is smaller halogen, but you are not supposed to write FI7 आप नहीं लिख सकते. This is not possible. This is not possible. F cannot take this place here. ये possible नहीं होगा, right? So if my bigger halogen is Bra, so the second one is going to be the one written with the dashes should be a lower halogen. ये फ्लोरीन हो सकता है या क्लोरीन भी हो सकता है, right? आयोडीन नहीं होगा. So Br I3 possible नहीं है. This is how you have to remember. So IF5 possible है, ICl5 भी possible है, ICl3 is also possible. So these are possibilities, but you are not supposed to write FI5. ये possible नहीं है. So this is the meaning of it. So interhalogens are of three types. So four types है. XX, XX3, XX5, XX7 type of interhalogens. मोनो ये एक 1:1 रेशियो में होंगे ये. So these are in 1:3 ratio, right? So whereas these are in 1:5 ratio में, these will be here, right? Interhalogens. When a halogen reacts with another halogen forms a compound, we call it as interhalogens. How can we name them here? इसको नेम भी कैसे कर सकते हैं बोलिए, नेम्स आपको बोलना चाहिए. एक एक एग्जाम्पल ले लेंगे. सो फ्रॉम दिस वी विल स्टडी इट. सो वी गॉट ClF, ClF3, right, BrF5 and iodine F7. So chlorine fluoride, chlorine trifluoride, bromine pentafluoride, iodine heptafluoride. So these are the names of these compounds. Okay, interhalogens. So hybridization, the nature of the bond will be studied in the next class on Monday, right? So the Board of Intermediate has declared that your results will be announced on Tuesday, that is 22nd April. Okay, so see you next time.